record to this computer? Does it say it's recording?
Yes.
Yeah.
All right, let's go. It's the usual incredibly smooth start to a lightning talk where I go, is it recording? Okay. Hello, and thank you for attending my lightning talk. In this one, I'm going to be giving you an overview of the IOFS package in Go. I hope by the end of this talk, you should have an idea of the main concepts around it and have some ideas as to how to use it in practice in your own work. So IOFS is concerned with reading files and working through directories of files. But it's important to note this is only a read-only package, so you can't do any kind of writing of files or creating of files or editing of files. Excuse me. Like any good Go package, its focus is very clear and it has a relatively small surface area of an API. It just offers a few public functions and a few types. So in this case, this isn't all of it, but these are the ones that I kind of picked out. So it lets you search for files in a directory using some kind of glob. You can obviously read a file and you can read a directory and you can also walk through a directory as well. But the thing to notice here is that each of these functions take a thing called an FS. So FS, which stands for file system, presumably, that's an interface that's defined by this package. And as you can see, it's very simple to implement. If you have a type that has an open method on it that returns a file or an error, you can now use that type with those functions defined before. So the design of this package pushes you into writing code that accepts this interface. And if you do that, you can then use all of these functions defined earlier to read your files and work with directories, and it allows you to make your code agnostic of file systems. There's another interface that you should probably be aware of, defined by the package, called read_fs. And what this does is it embeds the FS interface into itself and then adds another requirement in the method set to read directories. And what's interesting is if you read through the source code of some of those functions defined before, you'll see that it actually does type assertions on the thing you pass in and kind of changes its behavior depending on whether you've bothered to implement just the FS interface or both the read_fs interface as well. So far, we spoke very abstractly, right? Like I can pass in abstract things into these functions and things will happen, but that obviously begs the question, how do we actually use this code concretely? Like, what does the standard library give us? So as you'd expect, the standard library gives you ways to work with a normal file system. So in this case, we can use the os.dirfs function, which gives us an FS, and then we can use that with the functions defined in the FS package. So in this case, I'm calling the read_dir function in the FS package, and I'm passing in the result of an os.dirfs. And that gives me a list of files in that particular directory. And then I could iterate over those files and open them or do whatever I want to do. And what the standard library also gives us is this new package called fs_test, which is kind of synonymous with http_test. It allows us to write tests against our code that uses the FS interface. In this case, to mock out a file system for our unit tests, all we have to do is construct a map. And it's just a map or string, which is the file path, to a thing called a map file, which just represents a file in memory. So here's an example. In this example, I'm testing a hypothetical blog post package, which will take some posts from a directory of files. And what's nice about this is rather than having to maintain some test directories of files or multiple directories of files for multiple tests, I can just simply construct a map of a virtual file system in order to test the behavior I want. So this makes testing code that works with reading files so much simpler. And then for the real code, I just plug in a real implementation. In this case, I'm plugging in os.read_dir. So this shows that how this simple design decision of accepting this FS interface makes testing our code around reading files far more pleasant. So this package I was talking about got released in Go 1.16, and what was also released on 1.16 was the embed compile time directive. And the basic idea of embedding is that by adding a special comment to your code, Go will know to include a file or files packaged up inside your binary. You can then reference these files inside your code. So this can make packaging up your application that relies on static assets substantially simpler. So the really basic case is if you just want to embed the contents of a single file as a string, you just do go embed the file name, and then you just do var version string. And then so long as that file lives where you're compiling from, that'll get included into your binary, and then you can just use that data as if it's just normal data in your program. But it doesn't just have to be text files. So you can embed other kinds of files and just have them represented as byte slices. But if you want to embed a directory of files, you do this. And as you've probably guessed, embed FS is just an alias for FSFS. So all those useful functions that the FS package defines, in the standard library, and all the ability to test it as well, that all comes out of the box for free. So you can treat your embedded file system exactly the same as if it was a normal file system, both in respect to your real production code and your testing code, which I think is pretty neat. So as I said, FSFS is an interface. So anything that has that open method can be used as a file system. And if you add the readdir method, you can then traverse your file system as well. So that means that we could happily implement our own versions of file systems for things that look like file systems, and then reuse those functions. Now, to make sure that you're all not sleeping, it's time for audience participation. Can any of you think of anything you use in your existing or previous projects that could be sensibly modeled as a file system and take advantage of this approach? Someone be brave.
Okay, I don't remember the settlements thing that much, but don't they use like UFX files and they transform it and stuff?
But where do those UFX files come from?
S3.
And what do people say S3 is like?
File system.
It's kind of like a file system in the cloud, isn't it? And today's hero, Harry Henderson, has made a GitHub package where basically he's implemented the FSFS interface for a bunch of stuff. And you'll see there that Amazon S3 is included. So in theory, not even in theory, in practice, what you could do is bring in his library and change it so that your S3 calls use this library, and then you get back an FSFS. And then you can just use those functions. And then it lets you treat S3 as if it's just a normal file system. I think that's pretty cool. And there's other things as well, secrets manager and all these other things. So I think this is actually a pretty cool idea. Like the fact that you could treat all these things in the same way, but also test them in the same way, strikes me as quite a powerful thing. So to wrap things up, if you're reading data from something that's file system-like, you'll probably want to leverage this interface and use the functions provided from the standard library. And whilst you probably won't be writing extremely generic functions that have to work with S3 and a file system and an embedded file system, it's not unfeasible for you to be working on a project that does work with those things in isolation. And if you use this package and use this approach, it will let you take a consistent approach to reading data. And that will mean that your implementations should all look the same, it should all feel consistent. And importantly, all your tests can also take the same approach and read consistently as well. There's a chapter about this in Learn Go Test, which gives you a kind of more practical example to work through. But that's the end of my lightning talk. Thank you for listening. Are there any questions?
Yes, from me.
Over it.
I think you previously mentioned, maybe yesterday, that you can use this embed thingy with different environments. Like you can have a production and you can have development environment and change the files based on that.
Yeah.
How does that work?
So there's a thing in Go called build tags, which can let you kind of compile things conditionally based on different sort of scenario. How do I explain this?
Conditionally at build time rather than at run time.
Yeah. So yeah, effectively what you can do is with build tags, you kind of send the tag into the go build directive, or even like go test and things, and it lets you effectively build different parts of your software, like we'll build your software slightly differently or test your software slightly differently. So that's how you could do it. But you could also control it at a kind of infrastructure level as well, I suppose. Like if you build your binary and it relies on, I don't know, version.txt, if your infrastructure brings in version.txt and puts it there for you, you know, if you build the binary there, then that would give you a different result if you built it somewhere else. So there's a few approaches. Sorry, I'm losing my voice a bit. So there's a few ways you could do that. I'll confess I've never really kind of played that myself. I've only really started playing with embed yesterday, so I'm not too familiar with it. But there's a lot of kind of like, I started reading like some blog posts and stuff, and people have some very interesting ideas around it. Interesting doesn't always mean good, but it's definitely worth looking into, I think.
Thank you.
Okay, if there are no more questions, I will stop sharing and stop record.